So, Calvina, what is the name of this lesson?
Area between two curves.
Yes, area between two curves. So just looking visually. Shh. Lauren, what do you think we're finding this time? Lauren?
Visually, the area?
Yeah. Between?
Two curves.
Yay! So, for example, rather than just the area between the x-axis and a curve, the area between two separate curves.
Oh, nice.
How would you do that? Oh my goodness. So we'll carry out the below investigation to see how to calculate the area between two curves. So doing this kind of thing again. So investigation, area between two curves. Consider the area between the two curves x squared plus 3x and x minus 2 from the lower bound being negative 1.5 to 3.5. So negative 1.5 being back here and 3.5 being here. So what did I write? What's here? Notice that regardless of whether f and g, so f of x is the red curve. What kind of curve is f of x? Bella. Oh, you're looking at the notes, sorry. F of x, what kind of curve is f of x, Bella? Starts with Q. Oh, quadratic, sorry. And what kind of curve is, what kind of function? Linear, nice. So, okay, so notice, so that's what f is. F is the quadratic and g of x is the linear one that they happen to give you. So notice that regardless of whether f and g are positive, negative, or 0, the height of the rectangle, see they've divided them up into different rectangles. How many rectangles do we have? 5. They split it up into 5 rectangles. The height of the rectangles is always given by f of x. So if you sub the x into the function, it gives you the height. The top curve minus g of x, the bottom curve. That might make no sense whatsoever. So let's go on. Fair enough. So let's go on to the investigation to see what am I going on about. So notice that there's 5 different rectangles. We're going to work, what do you think is the width of each of those rectangles?
1.
Yeah, it's all just 1. See from 2.5 to 3.5, 1. 1.5 to 2.5, 0.5 to 1.5. The widths are all just 1. And we're going to calculate, we're going to work out the heights of them. You can probably look at the graph a bit because they've given you a nice graph. So the width of all of them, what should I put for the width? The width of all of those rectangles, it was all the same number.
So all 1?
They're all 1, yep. So you can put all the widths as being 1.
Would I ever get rectangles that aren't the same width?
That would be a bit mean. This is more just a proof. This is more just a proof of the theorem. The whole theorem of integral calculus, it's all about like adding up areas of rectangles and like in theory. So we only did 5 rectangles, but in theory, how many rectangles are they adding together? It's approaching
0.
infinity. Yeah, they're approaching an infinite amount. So integral calculus assumes that you've got an infinite amount, or the amount of rectangles that you're using is divided into, and it approaches infinity. So notice what they did was here. Why do you think they? So that this for the first rectangle, negative 1.5 to negative 0.5. Why do you think they're subbing in x is negative 1? Have a look at the graph. So for this little rectangle, why do you think they're subbing in x is negative 1? It's a midpoint, yeah. Notice they're using kind of the midpoint. Because this negative 1 correlates with, if you sub in negative 1 into here, what's negative 1 squared?
1.
1 plus 3 times negative 1? Negative, close. 1 plus negative, negative 3 is?
No, negative 2.
Negative 2. So see how this point here corresponds with negative 2? And then for this one, if you sub in negative 1 into here,
Which one?
negative 1 minus 1 is negative 3. So see at negative 1, this one corresponds with negative 3. So we're using the midpoint as the x value for each rectangle. So the midpoint, whereas before, remember in the investigation we did one with the lower bound and then we did another one with the upper bound. We're just using the midpoint each time.
I'm confused for what's the midpoint.
Yeah, but I'm confused why it was between like negative 0.5.
Yeah.
No, actually,
Yeah.
the midpoint of that interval.
Yeah, exactly. So what would be the midpoint of this rectangle, of this interval?
0.
Yeah. The negative 3, Grace, comes from, see for the red one, it's at negative 2, and for the blue one, it's at negative 3. So negative 2, and it's always minus. Yeah. Minus negative 3. So same for the next one, we're going to use this value and this value. I might leave those there so you can see it a bit more. That value and that value. We could sub it into the equation to double check, but I'll just let you know. They've given you a nice one where you can just look at it, to be honest, and get it from there. So I'll just scroll down a bit so we can see that. Maybe I'll zoom out a bit so we can see the whole thing all together. So nice. So this one, so the x value that corresponds with that interval, the midpoint. So we might just want to make a point. This thing is -1 is the midpoint. Because that's when I first looked at it and went, what that? Of the interval, that interval there, -1.5 x, -0.5. So -1 is the midpoint. So what would be the midpoint of the second interval? 0, yes. We'll go f of 0 minus g of 0. What? That's, by the way, if you're wondering what on earth is that, that's f of 0 minus g of 0.
F of 0 minus.
That's just
Why do you do that?
that's a little spot. There's little points in the board where it's just really off. And if you hit it, then it does that. F of 0 minus g of 0. Whereas if that part of the board was at the top of the board, it would have been okay.
Why do we do that?
Yeah, why do F of 0 minus G?
Remember what we are subbing in as the midpoint? We're trying to work out what is the height. See, we're working out the height of the rectangle.
So why don't we just sub it into the F of X one?
Because the height of the rectangle is the difference between the two.
Oh, okay,
Oh,
yeah.
yeah.
Oh, yeah.
Yeah.
Okay.
Yeah, that's right. Yeah, it's a good point. The height of
Gotcha.
the rectangle is the difference between the two.
You should write that.
Yeah, isn't like random numbers. Okay, so basically it's the equation for both lines, so one minus the other.
Yeah, and the number x we're subbing in is the midpoint, the middle value. Because we've just noticed the way they've drawn them, they've kind of drawn the rectangles based on the middle of where the rectangle is. So what we've got is, so that's, would you say that's 0 minus -2, which equals,
Wait, so F of 0 is what?
f of 0 is, on here, that would be 0, and g of 0 is -2. So subtract, because we're finding the difference. The difference will tell us the height of the rectangle. I'll just check I've got the right numbers. And then did you get 0 minus -2 is being +2? And then remember area is length times width. Maybe equals length times width, or width times length. I think you can do whichever way you want. Length times width, width times length. So in that case it would be 2 times 1, which equals 2. And then what would be the midpoint of that interval there? 1, yep. So you notice we're getting nice numbers.
Wait, so why did you put
Just doing this.
length times width?
Just did it again. Write it slower.
That's how you find the area.
Even when you write it slow, it does that.
Because it lasts.
What
And
does
the
that
height
called?
is 2. So height is like the length.
Yes.
Yeah, exactly. Yeah, base times height kind of thing, length times width. You might want to call it base times height for the area because it's a bit more set up like that, isn't it? Base times height. So that's f of 1 minus g of 1. So f of 1, they've given you a nice one. You could have subbed in 1 into the equations and calculated it, but they've given you a nice one so you can just look at them.
Imagine this bad rules. Oh, that should make
The height, the height. 4 minus, did you get -1?
It is.
Yeah, it is.
Yeah.
So equals 5.
Yeah.
And then so it's 5 times 1. Or width or 1.
What are you talking about?
Then we'll do another one. What's the midpoint of the next interval? 2, good. They're nice whole numbers, which is good. F of 2 minus g of 2 equals.
Wait, where is F at 1?
F of 1, just go to when x is 1
Uh-huh.
and go up to where it's on the F.
Yeah.
The F is the red one, the red parabola, and the G is the blue linear. So F of 2 minus G of 2, did you get 10 minus 0?
Yeah.
Okay, yeah, 10 minus 0 equals 10. And then 10 times 1. And then the last one, it's what's the midpoint of that interval? 3, yeah. So go to cross to where x is 3, and the height, the f of 3 will be 18, and the g of 3 did you get as being 1?
Yeah.
Great. F of 3 and enter again. Okay. Let's pause this. Isn't that weird? Like, it's not like, I sometimes think that it's because I got to unpause it. And then so f of 3 minus g of 3 is 18 minus 1. Because you see on here it's 18 minus 1, 17, and we'll continue this next lesson.